So far, we've seen a couple of different ways to refer to objects in the Mac scene. One way is to use the scene object's name prefixed with a $sign, like $box01. Another way is via the object set global variables like geometry, camera, lights, etc. that name various standard sets of objects in the scene. MacScript also supports naming object sets with name patterns, much like the patterns you can use in the Select by Name dialog in Macs. And you can use object path names that are similar to disk file path names to name a specific object down inside a linked hierarchy. I would like to explore all of these now in more detail. First, the standard object sets. There are 9 of them in total. 7 correspond to the standard Mac's scene object categories: geometry, lights, cameras, helpers, shapes, systems, and spacewarps. The set named objects contains all of the objects in the scene, and the set named selection contains the current scene selection. All these sets are collections, just like arrays, and so they can be looped over and support automatic collection mapping. All the sets are also dynamically updated to reflect the current state of the scene as objects are created and deleted, selected and deselected. If you want to snapshot the state of one of the sets at some point in time, you can convert it to an array like this, using the as conversion operator. This creates an array containing the current objects in the set. This is often useful for saving and restoring selection sets, or processing a set with code that changes the set on the fly. For example, if I wanted a script to loop over the current geometry and selectively delete, say, distant objects, I could not just loop over the set like this, selecting distant objects and deleting them. Any deletes would change the current geometry set on the fly and mess up the loop, which internally is stepping an index through the set, and so it would get out of step. This is also true of looping through the selection set and changing the selection, say, with a deselect function. One way to avoid this is to snapshot the set into an array at the start of the loop, like this. Here you see me converting the geometry set into an array and then looping over the elements in that array. This means that although the geometry set will be affected each time I execute this delete, the snapshotted array will be untouched. Object sets have many of the characteristics of arrays. You can access the count property to get the number of objects currently in them, and you can get at individual elements via indexing like this. Here I'm using the .count property on the lights object set to loop I from 1 to the number of lights in the scene, and using element indexing here to work on each individual light. I check to see if the ith light is an omnilight, and if so, bump its multiplier by 150%. As with arrays, you can also use collection mapped functions with object sets. So I can say select all the cameras, or delete all the lights, or move all of the geometry, or adjust a common property on the current selection, and so on, all with single commands, as you can see. Okay, let's look at path names now. They are generalizations of the dollar naming scheme we've seen already. The idea of a path name is to give you a way to name the path to an object or set of objects down through an object hierarchy. Here's an example scene containing a figure with body parts arranged in a common sort of hierarchy. The top level object is the torso, descending down through upper arms and upper legs, through elbows and knees, to lower arms and lower legs, and finally hands and feet. Path names look like this. They start with $, followed by a sequence of object names separated by slashes. Each name after a slash names a child of the object before the slash, so you navigate down through the hierarchy level by level. Here going from torso to neck to head, and here down one of the leg branches. Path names can help name an exact object if several have the same name, but are in different trees. I'll call select on the path names in these examples so we can more easily see what they name. As you can see here, selecting the head, and here, selecting the lower left leg. At any level in a path name, you can use a wildcard pattern to name a set of objects. These patterns are very similar to the ones you can use in the Select by Name dialog in the main Macs UI. A star in a name pattern matches any number of characters at that point, and a question mark matches exactly one character. So this example names all the objects whose names begin with left, the star matching anything after the string left. And so we get all of the objects on the left-hand side of the body. This names all the objects with ni anywhere in the name, the stars matching anything on either side of the string knee. And as you can see, we select both knees. You can use these patterns anywhere in a path. So this example names all the immediate children of torso, the upper arms and upper legs. And this example names all the objects 2 levels down from the torso whose names start with left, the left elbow and knee in this case. The star here as a path element effectively says, search down all the children at this level. As you can see, path names allow you to be exact about the specific levels in a hierarchy you want to work with. You can also search whole subtrees with the ... ellipsis notation like this. I've replaced the star in the previous example with ... So instead of matching at a single level, as the star did, the ellipsis says match at any level. So this will find all the descendant objects of torso whose names start with left. In other words, all of the descendants of torso on the left-hand side. As a shorthand, you can leave out the slashes around an ellipsis like this. So this example matches everything under all the objects whose names contain the string lower. In this case, all of the lower extremities. This pattern is a commonly used one for naming all the objects in a tree under a given parent. In this case, the whole figure. A set of objects named with a wildcard path name behaves exactly like the standard built-in object sets. So you can loop over them, index them, call auto-mapped functions on them, snapshot them into arrays, and generally pass them around as values. For example, this property assignment sets the radius of all the legs to 5, as you can see. And in this example, scales all the feet by 2 in the x direction. And this example rotates the left upper arms and upper legs by -35 degrees around the local y-axis. And finally, this loops h over all the right-hand side parts and prints their positions.